Okay, so a question on moving objects, maybe aeroplanes. It's in 3 dimensions here. So we're going to use the power of our calculator to find the answers, but we'll need a little bit of knowledge about relative positions of one object from the other. So as you read the question, you've got object P with a position and object Q with a position. And so the question asks about the initial distance between the objects. So that would suggest t equals 0. And part B, the shortest distance between the objects and the time when this occurs. I suppose we could also infer whether the objects collide or not once we've answered part B. So before we answer part A, let's just write down a single equation. And I've got it here ready to go. The relative position of P from Q. I don't suppose it matters which way around, the relative position of P from Q or Q from P. So we just want to find an equation that tells us the relative positions of the two objects from each other, and that's a simple subtraction. Okay, so let's go ahead and do that. So the x component, 5 subtract negative 4, that will give us 9. The y component, negative 2 subtract negative 3. That will be negative 1 subtract negative 3. That's negative 1 plus 3. That'll give us 2. And then 2 subtract 4 is negative 2. And then the same for the direction. We have negative 1 subtract 1 is negative 2. Negative 3 subtract negative 2. So that's negative 3 plus 2 is negative 1. And the final one, 1 subtract 2 is negative 1. So there we go. And from that simple equation, the relative position of one object from the other, we can now answer part A and part B. Part A and part B talk about the actual distance. We've got the relative position. So it's a simple step now from the relative position to write down now the distance between the objects. And that's straight from the distance formula Pythagoras. And that is just simply the x, y, and z components put into Pythagoras. So this is the x component, which is 9 minus 2t, and we have to square it, and then plus the y components, 2 minus t, and again squared, so just Pythagoras in 3D, plus the z component, negative 2 minus t, and we will square that, and there we go. So all we're going to do now is we're going to take that distance equation and we are going to draw a graph of it. Okay, so the y-axis will be distance between object P and Q, and on the x-axis will be time. So we've got a simple equation, an output variable with a single input variable being time. So let's go ahead and insert a graph. Okay, now I don't think on my T-Inspire I can just simply copy and paste across, but we'll give it a go. Oh, look at that, it copied and pasted across beautifully. Just go ahead and change the t into the x variable. Let's go and look at that. Okay, so the graph tells us all we need to know really, right? T equals 0 initially. We have an intercept here. This is the distance between the two objects. And the distance you can see decreases until it's a certain, the closest point is here, the minimum on the graph. And then the distance increases. I suppose if the objects collided, we'd have this minimum hitting the y-axis, as in the distance between the two objects would be 0. So that would indicate a collision. So let's just do two things. Control T turns on the table of values. And you can see that this is quite useful because now we've got x equals 0, it's time t equals 0 initially. The objects are 9.43 apart. I'm not sure if that was meters or kilometers. We'll go back and have a look at the units. And you can see that the distance between them is decreasing. 2 seconds decreasing, 3 seconds, and then between 3 and 4 it's increasing again. But of course, we just go back to the graph, analyze graph, look at the minimum, and we can see quite clearly that it appears at time t equals 3, the minimum distance is achieved, and that's 5.92. Let's go back to the question. and the question talks about the distances in meters. So the answers are indeed in meters. Let's just transfer it to the screen now. So A, the actual answer now. The initial distance when t equals 0, d equals 9.43. And B, t equals, again we do three significant figures, t equals 3, okay, so that's exactly 3, and it's 5.92. t equals 3 seconds, and d equals 5.92 meters. Let's just check that one again. 5.92. So there you go, the actual idea when you try and find the distance between two moving objects in 3 dimensions, also in 2 dimensions. If you first work the relative position of one object from the other by a simple subtraction of positions, and then feed that into the distance formula, and then graph the distance formula, we have all the information we need.